behind watching this video is to be able to make a factor tree to determine the prime factorization of a composite number. All right, so a factor, remember that a factor is a number that when multiplied with another produces a given number or expression. So if I would write a multiplication problem up here, 6 times 3 is 18. All right, 6 and 3 are factors of 18. They're numbers that can be multiplied to get the product 18. So 6 and 3 are factors. We can write factor pairs. All right, so a factor pair just means both of the factors, both of the things you multiply to get that number. So 6 and 3 are also a factor pair. We could talk about them individually and say 6 is a factor of 18. We could say 3 is a factor of 18. We could say 2 is a factor of 18. We could say 9 is a factor of 18. Those are all numbers that you can multiply to get 18. But we could say that 6 and 3 together are a factor pair of 18. 9 and 2 together are a factor pair of 18. We can use factor pairs for a lot of daily life stuff. So this is not just something you use in math class, all right, or if you have a job in math. Let's say Miss Ritchie is trying to organize her marching band, okay, and she has 30 members in the brass section. So brass, that's your trumpets, French horns, baritones, tubas, trombones, etc. All right, so she has 30 of them, and she wants to organize them in rows. When you see a marching band walking down the street, they're usually in even rows. So she wants to know how many possible arrangements are there. If she has 30 members of her brass section, how many ways could she line them up? So, what are some factors of 30? All right, we could do 5 times 6, right? That means she would have 5 brass players in the first row, 5 in the second row, 5 in the third row, 5 in the fourth row, 5 in the fifth row, and 5 in the sixth row. Okay? She could also turn it around. It would look different if she did 6 in each row and there were only 5 rows. Okay, that would look a little different. The band would look a little wider marching down the street and a little shorter going back. All right? She could also organize her band in 15 rows with 2 in each row. That'd be a really long, skinny marching band, right? I'm not going to write it all out, okay? But you'd have to do that 15 times. Or she could have a really wide marching band that maybe has to spill over onto the sidewalks as they go down the street and put 2 rows with 15 people in each row. All right? She could do 3 people in each row and have 10 rows. Or she could have 10 people in each row and do 3 rows. So she has many options. Or I guess you could say she could even do 1 person in each row and have 30 rows, or 30 people all in 1 row. All right, so looking at that, there are 1, 2, 3, 4, 5, 6, 7, 8 possible ways she could arrange her marching band. List the factor pairs of each number. So 14. What are numbers that can be multiplied to get 14? We have the obvious 1 times 14. If that's all there was, 14 would be a prime number. But we know we can also multiply 2 and 7 to get 14. All right, so this is a factor pair of 14. 2 and 7 are factors of 14. This is a factor pair of 14. 12. All right, I know I can multiply 1 and 12. I know I can multiply 2 and 6. 2 and 6 are a factor pair. 1 and 12 are a factor pair. And 3 and 4 is a factor pair of 12. 3 just by itself, I can say 3 is a factor of 12, but I can only say it's a pair if I also include the 4. All right, so now we're going to work on factor trees. We're going to make things that look like this. And the goal of making things like this are to break our number, 60 or whatever number I give you, down into a math problem of just prime numbers that can be multiplied to get that number. And it will make a lot more sense after we do it. So let's do that. 48. I would suggest you write this down in your notebook so you have something to look back at tomorrow in class. So 48. Give me 2 things multiplied that equal 48. Ready, set, go! Oh, wait, except for 1 and 48. I heard somebody say 1 and 48. 1 and 48, when we're trying to make a factor tree, will not get us anywhere. So two factors that when multiplied together give us 48. I heard someone over there say 6 and 8. So let's write down 6 times 8. Hint, when you make a factor tree, always write the smallest number over to the left. Okay? So 6 and 8. Yep, they give me 48. I heard somebody else say 12 and 4. Smallest number on this side. All right? These are two separate factor trees. I just want you to show that we can do it with any factor pair besides 1 and 48. All right? So these are two separate factor trees for the number 48. They are both correct. You can do it either way. You could also do it with other numbers that equal 48. So you could have said 2 and 24, and you will still get to the same answer. Okay? Now, once you've made your first factor pair, we're going to look at these two factors, 6 and 8. Is 6 composite? Can I break it down again? Yes, I can. I can do 2 times 3. So write your smaller numbers to the left, 2 times 3. Okay? Now we're going to break down 8. 8 is composite. So 8, let's do 2 times 4. Smaller numbers to the left. Okay. So now we're going to look at our next row of factors. Let's start with 2. Here's my 2. Can I break that down? I cannot. 2 is prime, so I'm going to circle it. All right? We're stuck with 2. It's prime. I can't break that down into anything except 1 times 2. All right? Let's look at the next one. 3. Is that prime or composite? It's prime. All right? I can't break it down, so I'm going to circle it. That's the goal, to get all prime numbers going across. All right? Next one. 2. Another 2. We know that's prime. I can't break it down. 4 is composite. I can break that down again into 2 times 2. Okay. Now, my last step is to write this multiplied out. So all my circle numbers I'm going to write in a multiplication problem, ordered from least numbers to greatest. So here's 1, 2, 3, 4. 2 is being multiplied. 1, 2, 3, 4. And then we also have this 3. Let's not forget about that. I ordered my numbers from least to greatest. Now, this is my prime factorization of 48. Let's check it. Your prime factorization, when you multiply it out, should always equal the number you started with, which is 48. So we're going to try 2 times 2. That's 4. 4 times this next 2 is 8. 8 times this next 2 is 16. 16 times 3, is that 48? Yes, it is. Okay, so our prime factorization works. Now, let's apply what we've talked about with powers to this. Okay? So, is there another way that I can write 2 times 2 times 2 times 2? So I don't have to use up so much space. I can write 2 as my base. 2 is my factor being multiplied. How many times am I multiplying it? 1, 2, 3, 4. So we could write that as 2 to the 4th, and then still multiply all that by 3. So both of these are the prime factorization of 48. Both work. What was I going to say? I just lost my train of thought. Oh, you'll notice that every number in the prime factorization is a prime number. That's the goal, to break 48 down into all prime numbers being multiplied. Now let's check this one over here. All right, I said you could do it using any factor pair, and we use 4 and 12 over here. So let's break down 4 into 2 times 2. Let's break down 12 into 2 times 6, or 3 times 4. Either one will get you to the right spot. Now I check my next row. Prime, prime, prime. Oh, composite. All right, so let's break that down. 2 times 3. Okay, now we'll check this row. Prime, prime. So I get 1, 2, 3, 4. 2 is being multiplied. And 1, 3. Or 2 to the 4th times 3. Is that exactly the same as what I got when I used 6 times 8 to start with? Yes, it is. All right, same answer, just using a different approach. 21. Let's do the prime factorization of 21. Okay, so give me a factor pair that equals 21. Oh, heard somebody yell it out. 3 times 7. All right, now let me check this row. 3, can't break it down, it's prime. 7, oh, can't break that down, it's prime. So the prime factorization of 7 is just 3 times 7. And those are both prime numbers. All right, 30. Lots of choices. You could do 6 times 5. You could do 3 times 10. You could do 2 times 15. Let's do 3 times 10. All right, so now I check this row. This is a prime number. Circle it. 10, I can break it down more. 2 times 5. Now I'm going to check my next row. 2 is a prime number. Circle it. 5 is a prime number. Circle it. All right, so now I'm done. I can't break down any numbers. I'm left with 2 times 3 times 5, which is my prime factorization of 30. And let's check it. 2 times 3 is 6. 6 times 5 is 30. All right, for class tomorrow, I did not ask you a question in the video, but I would like you to tell me 1 through 5, 5 being super well, all right, if you get this video or not, if you get factorization so far or not. So if you really understand it, you're like, I got this, I did this before maybe, I just really know how to do it, I'm ready to go, you'll type a 5 in to the box on Edmodo and submit it. If you are really confused, type in a 1 and submit. If you're somewhere in the middle, you'll probably type 2